Assalamualaikum warahmatullahi wabarakatuh. Okay, so for this video, I will show you how to develop a calculation sheet for the cable sizing. Okay, so first of all, before we go to the items inside the Excel table, so what you need to do is so this part you need to fill up with your company name and logo. Put your logo here, your company logo here. This is your company name, so you must set or create what is your group company name and logo. Okay, so this is the project title. So this is only the proposed project title. You may edit your own project title. Okay, so this is the calculation sheet name. Okay, so project number. Okay, this is also the example of project number. So P is for project, 21 is 2020, 030 is the project number. Okay, so the client for my company is Universiti Malaysia Pahang. Alright, so you may put your own client name. Okay, so date this calculation sheet be made. Okay, so prepared by, put your initial, any of your group members initial, so check by any of you and approved by any of you. So make sure this is only the initial name. This is my name, NZJ, Nuzaiha binti Jamal. Okay, so this is the initial is NZJ lah. Alright, so we go straight to the item inside the table. Okay, this is the number of building that we are going to supply power. Okay, the number 1, 2, 3 until 6 you may add on. Alright, so this is supply to which building. Okay, from, let's say we take the power supply from the substation to the asrama building. Okay, so all things inside here is the data that we need to know in order for us to complete the cable sizing. Okay, so I have colored all the column. I have grouping the column into different colors. Okay, so this green color is in one group, purple color one group, orange color one group, blue color is one group, yellow is one group, and green, another green is for another group lah. Okay, it's not that another group actually, but it's, I have divided them into a small portion so that you may understand. Because of this calculation sheet will go we follow this procedure. Okay, first of all we need to determine the design current. Okay, so this is the first step. So the light green color is for the step lah. Okay, so what we need to know for to design the current. Okay, to determine the design current. Okay, so first of all we need to know the power TCL. Okay, so I zoom in the size so that you can have a better picture of it. Okay, so this is the power TCL in kilowatt. Alright, so you need to know the diversity factor in order for you to find out what is the power MD, power maximum demand, in kilowatt hour, in kilowatt also. Okay, so next is you need to know the power factor, voltage, for the system voltage, for you to calculate what is the maximum demand current. Okay, so this is the ampere. Alright, this is the ampere. So all this is the data. Okay, so this one you may calculate from this to data. Okay, for you to get what is the maximum demand. Okay, you can multiply CL times diversity factor. Okay, so this is the data that you need to know for you to calculate the ampere for maximum demand. Okay, so this is the alright. So you this is the IB. Okay, the design current. Okay, so what is the next step? The next step is select type and rating of the protection, which is IN. So from here you can select protective device rating from the manufacturer's catalog. Okay, so just put in the value. Okay, so this is the ambient temperature for the installation, and this is the CA. Since we are going, let's say we are going to use the XLPE cable in ground, so this is the CA for 40 degree ampere. For 40 degree. This is the CG, which is laid in ground. So okay, so you may put the data from the you can get this all those data from the manufacturer's catalog or from the BS standard. Okay, so next is IT. Okay, since this is the for the third step, we need to select the correction factor based on the installation condition, which is CA and CG. Okay, so for the next step, fourth step is divide IN by the relevant correction factor to give tabulated cable carrying capacity, which is IT. Okay, so this is our IT. We can get it from this IN divided by CA times CG. Okay, so next step is step number 5. Select the cable size that's suitable for IT. Since we know that our IT is, let's say, as the example is 196.1, so we need to determine what is our cable type. Since we are going to lay our cable in ground, so the insulation must be very good. Okay, so that's why I choose XLPE, SWA, PVC copper. Okay, this is the cable type. So number of cable that are going to be used is 4 core for 3 phase 415. Okay, so number of cable is 1 numbers. So the cable sizing, we can refer to the catalog from the manufacturer or from the BS standard. Okay, let's say just now we know that our IT is 196, so this is our IZAC must be more than IT lah. Okay, so 196 is the nearest one is 197. So we select 95 mm square cable. So also same goes to voltage drop. You can refer to the catalog from the manufacturer. For 95 mm square, the voltage drop for 3 phase or 4 core 3 phase is 0.45. Okay, so go back to your spreadsheet. Okay, so this is the cable distance, okay, from the input to the building. Okay, so this is the carrying capacity. We know that, okay, we know that IZAC must be more than IT. Okay, so our IZAC is 197, so our IT is 196, so it is okay. So next is we need to check the voltage drop. So the last step is check the voltage drop of the selected cable. So the voltage drop must be not more than 4%. Okay, so this is the voltage drop. Okay, from the formula we know that voltage drop is IB times voltage drop over, per ampere per meter times cable distance times 100 over the system's voltage times 1000. Okay, so let's say this is our voltage drop, which is more than 4%. So the status is not okay. Okay, how can you do the status okay or not okay? You can use this formula. Okay, if something and so on. Alright, if Y13 is not more than 4, it is okay, or else it is not okay. Alright, okay, then that's it for the one building. Okay, so from this spreadsheet you can list down all your building that you need to supply. Okay, alright, since our voltage drop is not okay, then we need to change our cable size to one size up, okay, to a larger size, which is 95. The larger size is 120. Okay, so 120, get the Isaac from the manufacturer catalog, which is 223, and also from the catalog the voltage drop. Okay, so cable distance is still okay. So only these two things that you need to change if you change the cable size. Okay, these three things. Alright, so we go back again. Okay, our Isaac is more than IT, but unfortunately the voltage drop is still not okay. So what can you do is you revise again the voltage, the cable size to one size up, which is 150. Okay, so 150, the Isaac is 251, which is more than 196. Okay, and the voltage drop is okay. Alright, so another method that you can use, which is if you don't want to use a larger size of cable, which is very hard for contractor to install for bending radius and so on, okay, you may change the cable size to a smaller size, but you use two numbers. Alright, okay, let's say you divided 150 times divided by 2. Alright, you get around 75 75 mm square. Okay, so you may choose 70. Okay, but the number of cable must be two numbers. Okay, since the number of cable is two numbers, the carrying capacity is times 2. Okay, you need to times 2 the carrying capacity of the for the 70. Okay, you can look here. This is 70 mm square. The carrying capacity is 167. So 167 times 2 because of the two numbers. Okay, same goes to the voltage drop. Okay, since the voltage drop for the 70 mm square is 0.6, but it is carried by two numbers of cables, so you can divide it by 2. Yes, you can divide it by 2. Okay, so you get it as 0.3. So the voltage drop is okay. Alright, so you may list down all the load that you have. Okay, let's say this is for the building Kuliah at Mengkel and another building. So list down all the load here and calculate the cable sizing. Okay, so this is the notes for cable sizing. Okay, you may put the notes here. Okay, this is the definition of IB. What is IB, IN, IT, and Isaac. Okay, you may put down the notes here. Okay, so that's all for how to develop a cable sizing calculation sheet. Okay, thank you.